Now, I got a couple of questions to go over. This question is from 2.1. I did cover this type of question, I think. I don't know if I did or not, but I'm going to cover it. And it's 2.1, number 5, number 21. This is where, and I like to tell students to think of a plane when you do these questions. The plane. So let's draw a plane. And a plane actually is a three-dimensional object. Okay, there's our plane. And I'm going to exaggerate this graph here a little bit. I'm going to exaggerate it because it's got arrowheads on the end of it, right? So I'm going to exaggerate it a little bit. And that's going to be that, and that's at 3, -3, and then we got this, and then we got it here, and that's it. We got that, and it goes like that. So I'm going to take my handy dandy plane, and I want you to tell me what that plane is doing. Which way do we read? Which way do we read, people? We read from left to right, Hubert. That's right, class. So this arrowhead is called negative infinity. And this arrowhead over here is called positive infinity. So let's take our handy dandy plane. And our plane, I want you to tell me what the plane is doing from left to right. So what was that plane doing from left to right on that part of the line? It's descending. Descending. So from negative infinity to -3, our plane is descending. Now let's look at the plane again. What's that plane doing from -3 to +3? Not doing anything. So it stays constant from -3 from -3 to +3 is constant. Think of it like it's on the runway, and it's just on the runway, and it's not doing anything. And then what is it doing from -3 to infinity? It's descending again. Okay, so think of it like this. Feet, and it what? Levels out, and then it gets to a point, and then it starts descending. So it's descending. If this whiteboard would work with me, it's descending from 3 to infinity. Oops. And that's how you do decreasing and increasing. So all you have to do is imagine a plane on the left-hand side and tell me what that plane is doing, and then write down the x values that is doing it. That's how you do descending and increase, or increasing, decreasing, whatever. Now, the domain of this function is negative infinity to positive infinity, because these two sorry, drawing with a mouse again. So basically, this is continuous from negative infinity to positive infinity. Range, you've got a dot here at whatever that is, -2. Okay, but it's covered because this negative infinity to positive infinity, because these two arrows, is covered. So the range is negative infinity to positive infinity. So just remember that plane. I guarantee you nobody in here has had a teacher use a plane before when doing increasing and decreasing. I'm cutting out because I didn't. Somebody is leaving the system in a shambles. Hold on. I'm going to go silent for a minute. I'm going to unplug this thing and plug it back in. Okay, guys, can you hear me now?
Yeah.
Okay, hopefully, and that's still recording. I hope it's still recording. It says 10 minutes, so I think it's okay. Somebody is leaving the system on and it's not, so I'm gonna write an email after class and make sure that somebody is addressed, because whoever the teacher in here before me, either yesterday or today, they're leaving the system on and it's not good. So I'm gonna address that. Okay, so all you got to do now is just make sure you put a plane on the left side of your graph and follow what that plane is doing and write down the x values that it's doing it. So from negative 900 miles to 3 miles approaching the airport, it's descending. And then once it gets to the airport, it levels out and does a circle at a constant elevation. And then it starts its descending 3 miles from the airport, 3 miles on the north side of the airport or whatever, and comes down. Okay, so, however you want to do it, but that's the best way to do increasing and decreasing values. Is this a test question? I do put one of these on the test, but it just asks for increasing, decreasing, and domain and range. So that's a good question. Hopefully I'm not cutting out anymore. Next question. This is 2.653, 2.623. 2.623, number 11. First of all, is it a test question? Yes. Any of these can be a test question because it's f of x. So we got f of x is equal to 5x plus 3, and g of x is equal to 4x minus 7. And they want you to find all of these. Now, this is not a test question by itself. Each one of these, that's a test question, that's a test question, that's a test question. I would never give you this whole thing as a test question, okay? But each one of these, so you got like 5 or 6 test questions here. So f of x is equal to 5x plus 3. G of x is equal to 4x minus 7. Okay? So, find f plus g of x. So that's your pre-algebra. 5x plus 3 plus 4x minus 7. Okay, so that's going to be 5x plus 4x is 9x. 3 minus 7 is negative 4. Okay, f minus. So that's going to be 5x plus 3 minus 4x minus 7. That's going to be 5x minus 4x is x. And 3 minus a negative 7 is 3 plus 7, which is 10. Now they want you to do f times. So that's your FOIL method. So 5x plus 3 and 4x minus 7. FOIL, 20x squared minus 35x plus 12x minus 21. And then 35 minus 12 is what, negative 13? I don't know. No, it's not 13. What is it? 23. Somebody help me out there. 20x squared minus 23. I suck at subtraction, so somebody check me on that. F divided by g of x. Well, you're not going to be able to do anything there except just put one under the other. So let's see, that's f. So 5x plus 3 over 4x minus 7. That's divided by. F composed. So that means I'm going to rewrite f with a big set of parentheses and plug in g. So that's going to give us 20x minus 35 plus 3, 20x minus 32. And now I'm going to do g of, so I'm going to rewrite g with a big set of parentheses and plug in. And that's going to be 20x plus 12 minus 7, which gives us 20x plus 7 minus, or what is that, 5? So there's 1, 2, 3, 4, 5, 6 test questions right there. And the only other thing I could miss is probably a addition or subtraction. I might have made a careless mistake with the math. I don't know that. 35 plus 3, I think that's right. 12 minus 7, I think that's 5. And that 35, 12, that should be 23. So there's 6 test questions right there. Okay, I don't see anybody saying anything, so I guess everybody feels good about it. Okay. Next question. 2.653/5. Okay, so use f of x and g of x to find the composition. Use a calculator if necessary. You don't need a calculator. So they want f composed of g, g composed of f, f composed of f, and then find the domain. Well, the domain is going to be tricky with this guy because when you plug in a negative, it becomes a positive. So you got to be careful. So what the first thing I would do is I would set the denominator equal to 0 before I, not the denominator, but the radicand. Let's set that equal to 0 first. So go over here and say 25 minus x, which nobody writes it like that. Negative x plus 25 is equal to 0. Negative x is equal to negative 25. It's supposed to be a square, no. I'm thinking. And then x is equal to 25. So I'm going to draw a little number line, and I'm going to put 25 right here. And of course, we know 26 is right here, and 24 is right here. So let's plug in. We know that 25 will give us a 0. Okay, we know that. So we can have 0 in the denominator, I mean the radicand, but we can't have a negative. So let's see what will give us a negative. What is 25 minus 24? That's positive. So these are positives. Okay, what is 26? 25 minus 26? That's negatives. So we can't have those. So our answer is, our domain for that radical is x such that x has to be less than or equal to 25. Or, we know this arrowhead's called negative infinity. So negative infinity to 25 is that's our domain. So go ahead and write that down, because that's our domain. You're not, anything with that radical, you're not going to be able to use numbers less than or above 25. So, with that being said, let's go ahead and do our algebra now. F composed. So that means I'm going to rewrite F as a big set of parentheses and plug in the square root of 25 minus x. And of course, I can't use those numbers in there, because if I get, it'll blow the function up. So I can't use 26. If I use 26, you can't take the square root of a negative number, and therefore I can't square it. So you have to do what's inside the parentheses first, then you have to do the exponent. So the function, I can actually cancel out the radical with but procedurally, I cannot plug in I cannot plug in anything above 25. So I don't know what they're asking here, but you can actually cancel this out and get 25 minus x. But the domain is different. The domain is going to be anything below 25. So that's that one. (25 minus x), because the actual radical cancels out the square. But the domain is, let's see, interval notation. That'll be parentheses, negative infinity. There we go, negative infinity, comma, 25, and bracket. And I shouldn't have to explain to you what a bracket is. So that should be your answer there. All right, now I want you to do G composed of F. So that means I'm going to rewrite G, and I'm going to rewrite G with a big set of parentheses. So that means the square root of 25 minus parentheses, and then of course x squared goes in there. All right, now just for giggles, now we've got f composed of x. Now we got to write this and set it equal to 0. So set that equal to 0. You're going to get 25 minus x squared is equal to 0. Negative x squared is equal to negative 25. Divide by negative 1, divide by negative 1. X squared is equal to 25. And x is equal to positive or negative 5. Let's graph it on the number line. Negative 5, 0, positive 5. So let's plug in -6. So what happens when we plug in -6? Well, -6 times -6 is what? 36. 25 minus 36 is a negative, so you can forget those. Now 5 will give us a 0, so we're not worried about that. 0. 0 gives us 25, so we can do that. So that's good. We okay here. Or you can put check marks. And then let's plug in a 6. Six squared is 36. 25 minus 36. Well, we know that we can't use that. So there's our domain in green. And you should feel good about yourself. So here we go. We take our handy dandy radical. And I can't find it. I think that's it. And 25 minus x squared I'm fantastic. And interval notation would be -5 brackets, -5, comma, 5, close brackets. And you should feel good about yourself. All right, now you do F composed of F. I'm going to let y'all do that one. Because that one's pretty simple, because it don't have a radical. So what would be x squared raised to the second power? Somebody give me that. Okay, that would be x to the 4th, Hubert. Thank you, class. Did I piss y'all off or something? Y'all mad at me? Y'all give me the silent treatment? Everybody loves the silent treatment. And what's good about x to the 4th? Well, it's not a fraction and it's not a radical. So what is, somebody tell me, what is the domain of something that doesn't have a fraction or a logarithm or radical? What is the domain? All real numbers. Good job. You are fantastic. Negative infinity to positive infinity. All real numbers. Yeah, all them all real numbers. And we feel good about ourselves. There's 3 good test questions right there. Now you might see this one on the test. It only has 3 parts, but I'd rather give 3 separate questions. But yeah, we all know that's the way you talk, Miss Maxon. We know you talk like that. Rail. All right. Okay. Okay. All right. Well, I don't have anybody to talk to, Miss Maxon, so that's why I'm talking to you. You're at least interacting with me. The rest of the class is pissed at me for some reason. I don't know. But I appreciate you being my friend. I appreciate that. Okay, that's it. That's the questions for today. So let's go over the last part of whatever section we're on. I can't remember if it's 2.4 or 2.6, and that is composition of functions and things like that. And I already got my handy dandy whiteboard fixed. And we're going to be working with the first quadrant. And we're going to be working with something that you're going to see in calculus. So you might want to put a little tab on your notes here, because this is your first unit test in calculus, and it's called the difference quotient. Now, you know, people in academia like to put big words on things. They like to sound like they're educated, all right? So they don't call the difference quotient, they call the difference quotient the difference quotient, but it has a 25-cent name. It has a name that you've been dealing with ever since pre-algebra and algebra 1. Does anybody happen to know that name? Those of y'all that are talking to me this morning through the chat, does anybody happen to know that name? Probably don't, because it's been muddled up and you don't know, because if you've seen the difference quotient, it can be intimidating. So I'm going to draw a function here. There we go. And I'm going to put 2 points on that function. We're going to put a point, it doesn't matter, put a point right there, and put a point right there. Now, that first point, since we read from left to right, that first point has a coordinate of x and f of x. Now give me a raise of hands of everybody that understands that first coordinate. X and f of x. Everybody good? All right, we got 3 or 4 of y'all paying attention. All right, good. Now, this other point has an x and y also. We're going to write it a little bit different, because this distance right here, oh, please, I put green. Damn Russians. All right. This distance right here, we're going to call that, you could call it D if you wanted to, but we're going to call it H. We're going to call that H. You can call it D if you want to, but most formulas are not written in terms of D. So this coordinate is x plus h. And the y is called f x plus h. Now raise your hands if you understand what I just did. I just assigned 2 coordinates to those 2 points. Now, the way that you did it a long time ago, you can put your hands down now. The way that you did it a long time ago is that first one was called x and y, and the second one was called x of, or the first one was called x of 1, y sub 1. The second one was called x of 2, y sub 2. But that's too redneck. So we're in academia now, and we're in this section, and we got to hold our pinky up. So we're not calling it x of 1, y sub 1, x of 2, y sub 2. We're not doing that anymore. We got to be sophisticated, and we got to call the first one x, f of x, and then x plus h, f of x plus h. Everybody with me? Okay, I want you to give me the slope of that line between the 2 blue dots. I want you to plug it into the formula for slope. Do that. Give me the slope of that line written with the coordinates that I've given you, using the slope formula that I gave you last week or this week or whenever we went over slope, calculating the slope. I want you to do that in your notebook. And remember me writing parentheses? It might help if you put parentheses, parentheses minus parentheses over parentheses minus parentheses, and plug and chug. So I'll give you a second to do that. Give you a few seconds, at least 30 seconds to do that. Now, the first thing somebody says is we can't do it, there's not any numbers. No, I'm not asking you for numbers. I'm asking you to plug and chug your new ways of writing X and Y into the difference quotient and see what you get, or see what you get when you plug it into the slope. So my slope formula is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, let's go back. We read from left to right, so this is x sub 1, this is y sub 1. This is x sub 2, this is y sub 2. So f of x plus h minus f of x over what? Well, x plus h minus x. And that gives us f of x plus h minus f of x over h. And that, my friends, is called the difference quotient. So somebody tell me, what's the 25-cent word, or what's layman's terms for difference quotient? What is it? That means I want somebody to type it in because y'all not talking to me today, so I figure you'd type it in. There you go, Miss Maxon. 25-cent word now, hold your pinky up, for slope is the difference quotient. Hopefully y'all see where I'm going with this. Have you been doing the difference quotient for the last 2 or 3 years in math with pre-algebra 101 and 102? Yes. Now you got to hold your pinky up and you got to write it different. Now, the first unit in calculus, you're going to be revisiting what I just showed you. This section of whatever section we're on, 2.5 or 2.6, is very, very, very important. I would put a tab on this part of your notes and put Unit 1 Calc. Because, remember I told you, calculus is not calculus. Calculus is 90% algebra. And if you forget, you better take this notebook that you're writing, you better study it before you go into calculus, because the first unit test is 90% algebra. So you've got to make sure you know this stuff. Now, how do you do the quotient rule, or the difference quotient? Well, you just plug in x plus h, wherever there's an x, and then you minus the function, and then you put it over h. That's all you do. So let's go ahead and do it. I got to see which homework we're in because I can't remember. I know we skipped a section, but I can't remember what section it was. Let me pull up the handy dandy course home assignments. I think it was 2.5 we skipped, or 2.3. 2.3, I think. Here it is. Here's our homework. I can't remember. And these last few should be difference quotient. Well, that's not it. Come on, they're not going to give you a difference quotient. Really? Wow. Well, I'm going to make up one. Somewhere they're going to give you the difference quotient. I don't know what section it is, but they're going to give you the difference quotient. Let me go to study plan. Let me go to chapter contents. Hold on a second. 2.6. Let me see if they put it in the study plan. Hello, 2.6. Thank you. I know I saw the difference quotient in y'all. There it is, right there. Okay, I don't know why it's not there. Let me see if there's another one. I wanted to start off easy. There we go. There's one. Okay, we're going to do a couple of these questions. I don't know where they are in your homework, but we're going to do them. And this is 2 or 3 test questions. These are test questions I will put on the test. And I will bet your bottom dollar, if you take a standardized test, you're going to see the difference quotient. All it is a slope. But in this case, you're not given 2 points, you're given a function. And that's the difference. See, the difference is the function actually is the slope. Okay, you see that right here. The function is actually the slope. But with the old formula of y sub 2 minus y sub 1, you're usually given 2 points. With the difference quotient, you're not going to be given 2 points. You're going to be given a function. Can't write with my mouse. Okay? So that's the difference between the two. This way, the old way, you're given 2 points. This way, the new way, you're given a function. So let's go back to the question at hand. All right, write the question down. And they're wanting you to plug and chug into the difference quotient. So I'm going to let you write it down first. We got to hurry up because this next class, there's like 3 or 4 that gets here like at 9:30 and they start standing outside the door. Oh. And then the teacher comes in and he has a gown and a mask and a face shield on. Really? Yep. Really. And nothing from the Math 110 class. I think y'all are mad at me. That's what I think. What did I do? Yeah, sounds like a reasonable guy. There you go. Yep, he wore a gown, a face shield, and a face mask. If I had to wear all that, I think I would just tell people that I'm not going to teach this semester. If I was that scared of catching whatever virus. 6%. But I got so many cattle antibodies in me that I ain't got to worry about it. Darth Vader, yeah. Yep, I was warming cows during the spring, and when you worm cows or deworm cows, you put Ivermectin on the back of their back, and for a 1,000-pound cow, you probably put 3 ounces. Well, the gun broke, and the dewormer went all over my hand, so I guess I don't have to worry about worms for a while.
We've been told at our job that the vaccine comes out in November.
Yeah, isn't that amazing?
Yeah.
And everything's going to disappear after, well, if it goes the way they want it to. It depends on who you are. If you're a rider, then you're going to burn more stuff after the election. If you're not a rider, then you probably are. Oh, I'm sorry, I just predicted the. Anyway, I think it's going to be a landslide, but that's just me.
Yeah, I work in
Anyway.
a pharmacy, so they told us prepare for November.
Yeah, prepare for November. People can't see through what's going on, then I'm sorry. And some of y'all go, what the hell is he talking about? Don't worry about it. You'll learn eventually. All right, so I'm gonna put this in blue brackets. And I'm gonna put this in green brackets or red brackets. I don't use red, but I don't feel like switching back and forth, so I'm just gonna do. So I'm gonna rewrite in blue brackets, I'm gonna rewrite the function with a big set of parentheses. Minus, in black, minus, and f of x goes back right here. Okay, so you're going to do that on every problem. Okay, whatever is the function, it's going to go in the blue brackets, and you're going to put a big set of parentheses wherever there's an x. Over h. And then somebody tell me, what am I going to plug into the blue set of parentheses? I'm wanting somebody to say it.
X plus H.
Thank you. Poor old Miss Davis. She had to break the ice. X plus H. Now you've got to do some algebra now. Now I'm only going to be able to get to a certain part before they start knocking the door down. So let's go ahead and get started on it. In blue, you're going to have to do 9 times x plus h squared, which is shortcut number 1, times x plus h to the first. So you're going to have to do a lot of algebra right there. Minus, and that 9x, it doesn't change anything. It just comes down. 9x cubed all over h. Now, when you do the algebra, you're going to get, I'm going to move all this over because I don't think I'm going to have enough time to do this. Like I say, I can't move it. Shoot. It won't let me move it. I thought I could move. Okay, you can't move this. Can I move the whole thing? Yeah. Y'all are impressed, aren't you? I know you are. All right, so here we go. I'm going to do the blue. So that's going to be 9 times x squared plus 2xh plus h squared times x plus h minus 9x cubed over h. Come you. Every time I hit black, turn on. Over h, I'm sorry. And now go back to blue. And that's going to be 9. And I'm going to distribute that x. That's going to be x cubed plus 2x squared h plus xh squared. Now I'm going to distribute the h plus x squared h plus 2xh squared plus h to the third minus 9x cubed. And now I need to distribute that 9 but I'm gonna try to cancel out something if I can before I distribute that 9. So I hope y'all appreciate me switching all these colors. All right, so back to blue. Let's see, x cubed, that's not gonna do anything. So x cubed is gonna be over here. So, and then 2x squared h plus 1x squared h is 3x squared h. And xh squared, 1xh squared plus 2xh squared is 3xh squared. And then plus h to the third minus 9x cubed, and that parenthesis is still there. And now you can distribute the 9. I'm going to go ahead and distribute the 9. And I get 9x cubed plus 27x squared h plus 27xh squared plus 9h. I think that's supposed to be the third power. Yeah. Minus 9x cubed. And this is supposed to happen. The x terms by themselves usually cancel out and you're left with only h terms. So 27x squared, I'm going to go ahead and factor out h, plus 27xh plus 9h squared over that h that we've been bringing right here. And those h's cancel. And your final answer to this problem is 27x squared plus 27xh plus 9h squared. That's your answer. Now, hopefully, you see why I'm telling you about calculus. If you're sitting there going, I have no idea what he just did, then you better be glad you took this class, because you'd be failing calculus right about now. Okay? The second person is going, I remember some of this, but I'm rusty like a bicycle chain. Then that's okay. Again, you're in the right class. And of course, if you invented this difference quotient, then you should have got money for it, because it's the basis of calculus. So some of y'all that invented it, y'all are doing good. All right, questions. F of x plus h? Is that a question? Anyway, all right, I'm going to look at the roll right quick. I remembered nothing. Thank God I didn't score high enough to get into calculus. Well, this, if you notice, all this is stuff that you've done in Algebra 2, Algebra 1 and 2. Okay? And that's what 80% of the whole semester of calculus is algebra. All right. And believe you me, I teach it every summer, so I know. And what do people suck at? They suck at the algebra. All right, let me go to handy dandy and log out. And let me go to I'm gonna turn off like I say, I gotta get going, because they're gonna start beating the door down here with their masks and gowns. All right, attendance tracker. I'm just checking to see if anybody's here that has not been here Monday and Wednesday. Set attendance week 3. Miss, let me look in who's in the class. I don't see Miss Boatwright. Miss Boatwright's not here. And let's see. Yeah, they've already closed me out. I'm looking for Miss Wilder. There's Miss Wilder. I've got to write an email because y'all wasn't here Wednesday. So I got to write an email and get those turned in. Okay, so I get Miss Wilder and Miss Ellis. Okay, anybody got any questions? So you should be working on the assignments that are on your, and if you want to go look at those two or three, I thought they had difference quotient in 2.6. I really did. So if they don't, we'll go over some more Monday. And believe you me, I know how important it is, so I'm going to go over it whether you like it or not. And I can't get out of this. Why can't I get out of chapter contents? Should be going to the, okay, anyway. I think 2.1, 2.2, 2.3, and 2.6 is on the homework, and you've got a long weekend to work on it. So I should see a lot of questions come Monday. Okay? All right, so I'm going to shut off the recording, and y'all have a good weekend.